Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. This is 5.1, Day 1, Variation Function Notes. We're going to look at three different types of variation. We'll have direct variation, inverse variation, and joint variation. All these things are just formulas. You're going to have to memorize the formulas, but once you do, they're not overly difficult. Okay? So direct variation. Let x be the speed you are traveling and y be the distance you travel. What happens to y as x increases? So if we're talking about the speed we're going in a car and how far we're going, as my speed increases, what happens to the distance I can travel in the same amount of time? Well, that is also going to increase. What happens to y as x decreases? So what happens to the distance I travel if I slow down? Well, that is also going to decrease. So what you're going to notice here, whoops, and I write decrease real quick. What you're going to notice when I have direct variation is that my x and my y will go in the same direction. So direct variation tells me that my two different variables will go in the same direction. They're either going to go up together or they're going to go down together. Either way, they're going to go in the same direction. The formula for that is y equals k times x. Now k is what is known as the constant of variation. No matter what I put in for x and y, k will always be the same once we find k. So what our job is now is, given y varies directly with x, so we know we're going to use y equals kx, we need to write an equation that relates x and y if the following are true. So what we're going to do is we're going to plug in these numbers for our y and our x to find our k. Once we find our k, we're going to rewrite an equation that we could use at any other situation that works with this, okay? So the first thing in my formula is y, so I put 14 in for y. Next thing is equals, then k times 3.5, because 3.5 is my x. Now if I divide by 3.5 on both sides, I end up with k by itself, and k would equal 4 in this case. Okay. Now that I know what k equals, I'm going to plug k back into my formula. So my formula was y equals k times x. Well, 4 equals k, so I put 4 in for k, and x, and there is my equation. Okay. We're going to do the same thing on the next two as well. My formula again is y equals kx, so I put 8 in for y. That's going to be equal to k times my x, which in this case is 2. Divide by 2. 8 divided by 2 is 4, so my k is 4. Now I'm going to plug that back into my formula, so y equals 4x will be my equation again. On to number 3. Y comes first, so 21 goes in for y. Then I have my equals, k times my x. In this case, my x is 3. If I divide both sides by 3, then my k will equal 7. To plug that into my formula, it'd be y equals 7x, and we're done with that problem as well. So that is the gist of what we're doing here. It's going to give us what our k and x values are, and then we need to find, our y and x values, what those are. We need to find our k value and then plug our k back into our formula in order to find an equation that we could use at a later time with different x and y values to solve for the opposite variable. Okay? So, inverse variation. If that was direct variation, they go in the same direction. Inverse variation, if we just think about it a little bit, is probably going to go in the opposite direction. But let's take a look. Let x be the number of tickets you can buy, and y be the amount of money you have to spend. What happens to the amount of money you have to spend if you buy more tickets? Well, obviously, you're going to have less money to spend. So as the number of tickets goes up, the amount of money I have left over goes down. What happens to y as the number of tickets you buy goes down? Well, that's going to increase, so you would still have more money left over. So just like with direct variation, inverse variation has a rule. As one goes up, the other will go down. Or as our first goes down, the other will go up. Okay? Our formula for inverse variation is y equals k over x, as long as k does not equal 0. All right? We have to make sure that k does not equal 0. But what we're going to do is exactly the same situation we did with direct variation. I'm going to take 6, plug it into my formula. So 6 goes in for y. I have my k over my x value. Well, in this case, my x value would be 1.5. How do I solve for k in this case? I would have to multiply by 1.5 on both sides. So 6 times 1.5 is going to get me 9. My k value equals 9. Now that I have my k value, I need to plug it back in my formula. So y will equal 9 over x. And that is an equation that I can use at a later date to plug x or y in and find the other variable. Okay. Same thing with 5 then. I'm using this formula up here, y equals k over x. So 8 goes in for my y. My k stays k. Put that over 3. I need to multiply by 3 on both sides. So 24 then would equal k. How do I put that back in my formula? Well, y equals 24 over x. Okay? On to 6, I have y equals 4 and k equals 2. I need to plug those into my formula. So 4 would equal k over 2. Multiply by 2 on both sides. 8 would equal my k value. So y would equal 8 over x. And I am done with inverse variation. Now, on to the back. Determine whether x and y show direct variation, inverse variation, or neither. If a variation occurs, write the equation. Well, what we're going to do here is we need to figure out whether or not I have direct or inverse variation. For direct variation, what I'm going to do is take y and divide it by x. For inverse variation, I would take x times y, okay? The reason why I do that is back here on the front. Let's look and see how we found our k value. Well, in problem 1 here, I took my y, which was 14, and divided it by my x, which is 3.5. That allowed me to find my k value, okay? And then with inverse variation, to find my k value, I took, right here, I took my x and my y and multiplied them together. So if I do that with these tables, then I can find out real quick whether or not I have direct or inverse variation. The one that I think is easier is taking x times y to start with. So if I take 2 times 9, I'd get 18. Now, in order to see if I have a constant of variation or a normal k value, what I have to do is continue through. So 4 times 4.5 is 18. 6 times 3 is 18. 8 times 2.25 is 18. And 10 times 1.8 is 18. Because each one of those, when I multiply them together, come out to the same number, which is 18, I know that I have inverse variation. Because remember, inverse variation, I will find my k by multiplying my x and my y. Now, it's really easy at this point to write my equation. 18 is going to be my k value. So I'd have y equals 18 over x, because I was using inverse. And there's my equation. So I think it's much easier to check that first one right away. I can go ahead and just type those straight into my calculator and see if I come up with the same number every single time. If I do, then I know my k value, and I can plug that right into my formula. Okay? So for problem number 8, the first thing I want to try is 1 times 4. Well, 1 times 4 would be 4. 3 times 12 is 36. So 1 times 4 is 4. 3 times 12 is 36. That's not going to work so well. So what I'm going to do in this case is I'm going to take 4 divided by 1. Well, 4 divided by 1 would get me 4. 12 divided by 3 would get me 4. It looks like I'm on the right track in this case. So what I did first, and I know I didn't write it down, but if I multiply these numbers together, I do not end up with the same k value. But if I divide them, 20 divided by 5 would be 4. 28 divided by 7 would be 4. And 36 divided by 9 would be 4. Now I have a constant k value. My k value is the same all the way through. So I know, because I did y divided by x, just like I said up here when I used direct variation, that I'm going to have a direct variation problem. Well, direct variation says y equals k times x. Well, we just found out that our k is 4, so it would be y equals 4x, and I would be done. On 7, I forgot to write one thing down. This is going to be inverse variation. Okay? You need to write down what type of variation you're using. All right? On to problem 9. Remember, the first thing I want to do is try to multiply them together. Well, 1 times 8 would be 8. 2 times 3 would be 6. Right now, I can say that's not going to work because my first two products, when I multiply them together, are not going to work, right? So then I can try 8 divided by 1, which would be 8, and 3 divided by 2 would be 3 over 2. Well, that's not going to work either. So if neither one work, there is a third option according to our directions. I can just say neither, and I am done. So for these type of problems, what you want to do first is you want to multiply x and y together. If after I multiply x and y together in each line, that comes out to the same number, then I have inverse variation. If that doesn't work, then I'm going to try to take y and divide it by x. If as I take y and divide by x on each row, it comes out to the same number, then I know I have direct variation. Okay? If neither one of those are true, then I have neither. All right? On to joint variation. Joint variation is the same thing as direct variation. I just add another variable. Okay? So y equals k times x times z. It means y varies jointly with x and z. The variable y varies jointly with x and z. Use the given values to write an equation relating x, y, and z. Now we're back to what we did on the front side with our first two sections. Okay, I'm going to take and plug these numbers in for my formula. So it'd be 2 equals k times 1 times 7. That means 2 would equal k times 7. If I can divide that by 7, so 2 over 7 would equal k. To write that as a formula I could use later, it would be y equals 2 over 7xz. Okay? So we treat it almost exactly like direct variation. You just have to multiply your x and z to start with. All right? On to 11, it says that y is negative 3, so I'm going to put negative 3 down. Then my k comes next. I'm going to multiply that by 4 and multiply the 4 by 24. When I multiply 4 and 24, I'm going to end up with k times 96. Divide that by 96 on both sides. 96 and 3 are both divisible by the same number. It is 3. So if I simplify that, I'd end up with negative 1 over 32 is equal to k. So my formula then would be y equals negative 1 over 32 xz. So like I said, direct variation and joint variation are pretty close together. They're almost the same thing. We just have to add one more variable to it. All right. So now we need to write an equation for the given relationships. Y varies directly with x. All it's asking us for is a formula. Okay. So this is the formula we used on the front side. Remember, it says directly, so it would be y equals kx. Y varies inversely with x, so y equals k over x. Y varies jointly with x and z. That's the formula we just looked at. So it's y equals k times x times z. Now, these next two are not our normal formulas, but we're going to set it up the same way. This says inversely. So we know that this is going to be y equals k over something because it's inverse. Now it tells us we need to use the square of x, not the square root of x. It will be the square of x. Well, the square of x is x squared, so it would be k over x squared. All right? And then the last problem here, it says z varies directly with y. This kind of changes it up on us a little bit. So I'm going to use z first. So z would equal. It varies directly with y, so this is going to be k times y. All right? And inversely with x. So z also varies inversely with x. So it would be z equals k over x. What we want to do at this point is put this all into one equation, all into one formula. So what I'm going to do, this is really over 1. The k's are both each in an equation. So what it's going to happen is z will equal k times y over x, and we'll be done. Okay? So the biggest thing to realize from these notes is you really have to memorize your 3 formulas. Your direct variation being y equals kx, your inverse variation being y equals k over x, and your joint variation of y equals k times x times z. I know that sometimes formulas are not super easy to memorize, but these aren't overly difficult formulas. You just have to get the names down. If you know that direct variation, and you got to get that formula in your head. Okay, inverse, get that formula in your head. Joint, get that formula in your head. The last piece is when you have a table and you need to figure out whether it's inverse variation or direct variation. Remember, inverse variation, if I multiply the x and y together, and that's the same on every row, then it will be inverse variation. If that doesn't work, then I'm going to try taking y and dividing it by x. If that comes out to the same number in each row, then it is direct variation. If neither one of those two things work, then it is neither. All right? Well, if you have any questions on this, make sure you come in and see me or ask some questions during class. Otherwise, thank you very much for watching the video, and have a great day.